Saxton Math Course 2, Lesson 2, Properties of Operation. In this lesson, we're going to be talking about different types of properties that deals with numbers. How numbers change, how numbers are used, and just a good idea of what to look forward to in this pre-algebra class. The very first operation I want you to see is the inverse operation. Inverse operation. If you notice in blue, I actually put check. The reason why I always try to say is almost like checking your work. It almost means the same thing. Inverse operation. 2 plus 3 equals 5. 2 plus 3 equals 5. And to check this, to make sure we did it right, you take your answer, which is 5, and you subtract this 3 from it. Now solve it. 5 minus 3 is 2. And the reason why it's called inverse operations is because we have the original problem, which is addition, and the check problem, which is opposite. What's the opposite of addition? Subtraction. It's the same thing with multiplication. What's the opposite of multiplication? Division. So to check a multiplication problem, you divide it to check it. Same thing with subtracting. If you have a subtraction problem, to check it, you add it. It's like pretty much the opposite to check, or the inverse of it to actually check. Let's take a look at the rest of the properties. Here are the properties for addition and multiplication. Numbers 5, 8, and 9, we're not going to be discussing today. We'll learn those later on. But let's talk about each of these properties. The first one is commutative property of addition. This means no matter how you switch an addition problem, the answer is always going to be the same. Here is the example. 2 plus 3 equals 3 plus 2. No matter how the numbers switch, the answer will still be the same. 2 plus 3 is 5, 3 plus 2 is 5. That's commutative property. So the same rules also apply for multiplication. No matter how you switch the numbers, the answers will still be the same. 2 times 3 is 6. 3 times 2 is 6. All right, let's go to associative property of addition and associative property of multiplication. This rule says that your parentheses move, your answer still stays the same. Doesn't matter exactly what the parentheses are, the answer still stays the same. So we have this one here. 2 plus parentheses 3 plus 4 equals 2. And I see a mistake here in this chart. It should be, parentheses should be here. It should be parentheses 2 plus 3 plus 4. No matter how you solve this, the answer will still stay the same. Let's do the left side first. 3 plus 4 is 7, plus 2 is 9. Let's move to the other side. 2 plus 3 is 5, plus 4 is 7. No matter how you flip the parentheses, the answer will stay the same. All right, let's take a look at number 4, associative property of multiplication. Same rules apply. No matter where the parentheses are located, the answer will still stay the same. 3 times 4 is 12. 12 times 2 is 24. And 2 times 3 is 6. 6 times 4 is 24. No matter where those parentheses lie, the answer will stay the same. Number 5 we're going to skip. We'll come back to that one later on. Number 6, identity property of addition. Identity property of addition says that if you add 0 to any number, the answer will be that number. So if I have 3 plus 0, it equals 3. Anything plus 0 will equal that number. 4 plus 0 equals 4. 5 plus 0 equals 5. 6 plus 0 equals 6. The identity property of multiplication follows the almost exact same rule. But of course, with multiplication, we use 1 instead of 0. 3 times 0 equals 3. You multiply any number by 1, and the answer will always be that number. Like I said, 3 times 1 is 3. 4 times 1 is 4. 5 times 1 is 5. And of course, the very last property is the property of 0. The property of 0 states that if you multiply any number by 0, the answer will be 0. 5 times 0 is 0. 6 times 0 is 0. A times 0 is 0. Let's take a look at an example to help explain this a little bit further. Example 3. Show 2 ways to simplify this expression. Justify each step. Because we're talking about 2 separate ways, I'm going to go ahead and show this example in 2 separate ways. Literally, which means I'm going to write this equation out twice. Alright, let's look at step 1. Step 1, of course, is just solving it like we normally would solve the equation. Parentheses first, we do 25 times 15, which is 375 times 4, which is 1,500. But we learn with the associative property that we can, no matter how you move your parentheses, you can still solve it the same exact way. The answers are still going to be the same exact. So in step 2, what we're going to do is we're going to change things around. Okay? What we're going to do, we're going to look at these parentheses first in the second step. We're going to take a look at these parentheses and these numbers. And we're going to see if there's a way we can actually solve this without actually doing the work for it. And of course, according to our rules, no matter how you turn numbers around in multiplication, the answer is still going to be the same. So it doesn't matter how we're going to do this with multiplication. We're just going to put numbers together that will work the best. So I want to move the 25 and the 4 together, because 25 times 4 is can get us a number that's really easy to solve. So to do that, I've got to move the parentheses. If I move the parentheses, I cannot put it in, I can't move it here, because if I move the parentheses alone, it's going to get me to 15 times 4. I have to move numbers first. What I'm going to do is I'm going to move the 15 and the 25 first. I'm going to do the commutative property first by moving these 2 numbers around. 15 times 25 times 4. Me moving these numbers around allows me now to do the parentheses. Let's change the parentheses over to where it's going to be around the 25 and the 4. So I did commutative property first by moving the numbers around, then did associative property by moving the parentheses around. And now we can solve this problem in our head. 25 times 4 is 100. 100 times 15 is 1,500. We follow the property rules to actually solve this equation where it's actually a little bit easier to solve. In example 4, we have simplify 100 minus 300. Reversing the order of the minute and the subtractant reverses the sign of the difference. We should automatically know that when we subtract 100 from 300, you're going to get 200. But because the minute and the subtractants are backwards, the answer is going to change from positive to negative. So we have 100 minus 300, which is 200. And because the bigger number is second, that means it's going to be a negative 200. In this next example, we're going to be finding the value of x and y in these equations that show. We have a and b. Let's take a look. 6 plus x equals 30. The x in this equation is called a variable. It's a letter representing a number, and that number is unknown. But we can actually look at the equation and mentally think of what x actually is. X equals 24. How about b? 6y equals 30. Y is my variable. Y equals 5. Now the question is, how did you come up with these answers? How did you mentally think about how you got your answers of these variables? If you notice, you took 30 and you subtracted 6 to get the 24. And B, you took your 30 and you divided by 6 to get your 5. If you notice, that's opposite of what actually showing in the equation. Because you have a positive 6, to get our answer, you subtracted it. It's a minus sign there. And the opposite of addition is subtraction. What about 6y? 6y is multiplying. What's the opposite of multiplication? Division. And that's how we got our answer. We're going to be using this later on to solve bigger equations. If you guys have any questions, make sure you schedule a time to come see me.